Hi everyone, in today's lesson we're going to be working with powers and exponents. And we're also going to be using the knowledge that we gained regarding the order of operations in this lesson as well. So let's take a moment and look at our focus for today. Our focus will be to write, simplify, and evaluate expressions using exponents. And by the end of today's lesson you should be able to answer this question: how can you recognize an exponent and what does it mean? So first off, let's establish some vocabulary. Some vocabulary I want to go over is what a power is, what an exponent is, and what a base is. First, let's start by talking about the power. A power is an expression using a base and an exponent, so it's the whole thing. An exponent tells how many times a number is being factored. In this case, it's telling us how many times the base is being factored. And the base is the number used as a factor. Now these words might mean really nothing to you and you need a visual representation of that. So let's take a moment and look at the parts and dissect a power. So as a whole, a power is the whole entire thing that contains the base and an exponent. So that is our power. Our exponent is that little number that's raised to the upper right hand corner of our base. Our exponent tells us how many times we're factoring our base. So in other words, we would take a look at this as our base of 5 is being factored 3 times, which would be 5 times 5 times 5. This is a very important reminder that I want to make sure that all of you get down. This is just an example. So 3 with an exponent of 2 is not the same as 3 times 2. That's a very common mistake. Please keep in mind that the exponent is always to the right of its base, always raised, and always smaller in size. So our base of 3 is being factored 2 times. That's very different than if you would accidentally multiply it 3 times 2, which is 6. When we write out our base, which is being factored 2 times, we would rewrite it using repeated multiplication. That would be 3 times 3, which equals 9. See the difference? So it's very important to keep in mind what you're doing with your base and how many times it's being factored. That is what our exponent tells us. Another thing that I want to make sure that you guys remember is to not forget about your negatives. So when you're working with exponent, it's super important to keep track of where your negatives are and what exactly is being squared. So these two examples look very similar. But in this problem, the value of 2 is our base. So we would rewrite this using repeated addition as 2 times 2, which is 4, and then we tack on our negative symbol. So negative 2 squared without any parentheses is equal to negative 4. While when we have negative 2 inside the parentheses, this is our entire base. So we are factoring negative 2 2 times. And I know that when I have two values with the same symbol, in this case I have two negative values, when we multiply them together it equals a positive number. See the difference in the two? So it's very important to make sure that you're keeping track of your negatives. Let's take a look at some examples with factoring using exponents and powers. So here we have a problem using repeated multiplication. We're asked to write it with exponents. So let's first identify what our bases are. We have the value of 3 and the value of 5. And 3 is being factored 2 times, and our operation is multiplication, and 5 is being factored 1, 2, 3, 4 times. So using exponents, this is how we would rewrite repeated multiplication using exponents. Let's take a look at another example. Here we have our bases of 6 and 9, and our operation is multiplication. 6 is being multiplied 1, 2, 3, 4 times, and 9 is being multiplied 1, 2, 3 times. So with this repeated multiplication using exponents, this is how we would rewrite it. Now we're going to take a look at a problem with the reminder that I talked about earlier. Our whole entire base is negative 5. So that's what's being factored 4 times. That's what our exponent tells us. So using repeated addition, we would simplify this expression to represent negative 5 times negative 5 times negative 5 times negative 5. Everything that's in that parentheses is also being factored. Now we're going to simplify this expression that has an exponent. We're going to need to use the order of operations. And since the order of operations states that we're going to solve for parentheses first, we are going to simplify 2 times 5, which equals 10. I'm going to drop down the rest of my expression, 26, and my operation of subtraction. Next step would be to simplify my exponent, and I would rewrite 10 squared as 10 times 10, which equals 100. So I would rewrite and drop down the rest of my expression as 26 minus 100. We're taking a larger number away from a smaller number, so our value is obviously going to be negative. 26 minus 100 equals negative 74. Let's take a look at writing more with exponents when we're dealing with numbers and variables. Here we have our number 9, which it's not being factored anymore. And then we have our variable a, which is being factored twice. Our variable b, that's only being factored once, so we don't put an exponent. It's just known that its exponent is 1. And then we also have the variable c, which is being factored 4 times. Another way to rewrite this is to take away the multiplication sign, because it would just be understood that multiplication is present in between all of these numbers and variables. So that's another way that you could write that. Let's do one more example together for you to see on simplifying this expression. And first we are going to simplify 3 squared. And using repeated multiplication, we are factoring our base 2 times. So we would rewrite this as 3 times 3, which equals 9. So I'm going to drop down the rest of my expression. 5 is being multiplied by 9 plus 8. Using my order of operations, I'm going to multiply first. 5 times 9 is 45. Drop down the rest of my expression, plus 8. And then I find the sum of 45 plus 8, which equals 54. Now let's take a moment to review what we've learned so far in this lesson using powers and exponents, and to see if you can answer this question. How can you recognize an exponent and what does it mean? If you have any questions regarding this lesson, please don't hesitate to let me know, and don't forget to answer the questions below and complete your homework. Bye guys!